also guided numerous postdoctoral fellows, PhD scholars, and master students throughout his career. Today, he will be talking to us about the topic hybrid pigeon pea challenges and opportunities. So, ICRISAT has been working in collaboration with public and private partners to increase and address the issues of low productivity in pigeon pea. They have developed several commercial disease-resistant hybrid pigeon peas, and they continue to work on the different challenges that we still face in terms of having pigeon pea hybrids. So with that, I will hand over to Dr. Prakash Gangashetty and invite him to take us through his presentation. Dr. Gangashetty, can you please open your camera and share your presentation?
Thank you. Thank you, Dr. Reddy. Can you hear me?
Yes, we can hear you. Please proceed.
Yeah, okay. Let me share my presentation. Hope you can see my presentation now.
We can see your presentation. Please go. Yeah, we can see it in slide mode. Thank you.
Yeah. Thank you, Dr. Reddy, and all the colleagues. Good afternoon, good morning, and good evening, wherever you are. So, as you know already, I'm working as a global pigeon pea breeding lead for pigeon peas, and today is one of the great day for presentation also for me, because today is ICRISAT's Foundation Day, which we are going to celebrate in a few hours from now. So I'll be presenting specifically on hybrid pigeon pea challenges and opportunities. So you all know what is pigeon pea actually. Pigeon pea is one of the crop where it is having a contribution to four important major aspects in our daily life, specifically to resilience to the climate. And second one is it also contributes to the food security, because normally in Asian population we eat at least 2 times a day. And also because of its high protein content, calcium content, magnesium and zinc, so it also contribute to the nutritional security wherever this is majorly consumed. And apart from that, it has a great contribution to the soil, specifically in improving its soil health in respect of biological nitrogen fixation and also the nitrogen use efficiency. And more recently, we also found out that this is one of the crop going to be having more carbon capture, and because of a deep root system and high efficient in phosphorus availability taking from the deeper layer of the soil. So it is one of the important crop which contribute to all these four important aspects. When we come to important of this crop actually, so if you take the forming systems wherever the drylands are there, specifically the choice of rainford forming system, wherein it acts as a multifaceted soil benefit to the soil and as well as to the forming community. And because of its protein and other nature, it is also one of the health and nutritional benefits to the consumers as well. The most importantly here we need to talk is its cultivation status. Specifically the cultivation, if you take globally, around 6.35 million hectare it is produced, and India itself produces almost around 4.4 million hectares. But the production is around 5.47 million tons globally and around 3.67 million ton in India itself. So India contributes almost around 80% of the pigeon pea to the world. But the average productivity when you take global and India, it is almost same. So you can see there is a huge potentiality of this crop, because the requirement of this crop is more in India and also in the Indian subcontinent and also in the Eastern Southern Africa. But India, if you take as a total importation value, almost it is around 633 million US million dollars import to the India. So that's why the government of India and also in collaboration with ICRISAT, we are working on Atmanirbhar pulses, specifically to curb the import of pigeon pea from outside India. So that's why this hybrid pigeon pea is more important now as a topic wherein we can improve our yields. So when we come to the how we consume the pigeon peas actually, so there are four different kind of consumption patterns wherein pigeon pea grows. Whole grain consumption, it takes around 10 to 20% globally. And green seed as a vegetable around 10 to 20% again, specifically in the Eastern Southern Africa region and also in the US and the Caribbean islands. And when we take as a pasta and noodles, pigeon pea flour used for this purpose, that is very less, around less than 5%. But the majorly it is consumed as a dal. If you go to any restaurant in the world which is having Indian name, it almost having dal everywhere. So the consumption of its dal as it's around 60 to 70%. So based on this consumption pattern in ICRISAT breeding programs, we design the market segments, wherein first market segment will be breeding for the high quality split grain dal pigeon peas. This will specifically contribute to the Indian subcontinent and also the Southeast Asia. The major breeding effort will be putting around 70%, specifically to breed varieties and also hybrid for specific market segment. Then the second market segment is on the vegetable pigeon pea and whole grain consumption. And specifically, we breed these kind of varieties for the Eastern Southern Africa region, wherein people go for it as a whole grain consumption and eating in the green stage. There we are putting around 30% of our global effort in breeding those kind of genetic material. So when we come to globally, ICRISAT is released around in 19 countries, around 135 varieties, and two commercial hybrid released from ICRISAT and NAR partnership globally. If you take 100, more than 135 varieties were released, but only two hybrid released in India. Specifically in India, we are breeding the hybrids. So when we come to milestones, how ICRISAT has contributed to the global pigeon pea breeding program. So this program has started in 1970s and delivered the first of its kind fusarium resistant variety to the world in 1986. And in 1991, we brought the world's first pigeon pea hybrid, that is ICPH8. And in 93, again, we brought one of the mega varieties of current today's cultivars, that is Asha, that released in 1993. That is the first cultivar which is having wilt and SMD resistant. Until today, it is having resistant to these traits. And in 2004, specifically, they brought the Hybrid Parent Research Consortium, wherein we can share our breeding material to the the private seed industries, and they can take and do the hybrid programs. And in 2008, this is one of the most important year in hybrid pigeon pea, that the 2671 ICPH was released, and this is the first CMS-based hybrid to be released. And in 2011, the first pigeon pea genome was sequenced. And up to date, now in 2023, we have launched a specific project called as the Network Project for India to specifically bring the early maturing hybrids and the varieties. And in 2024, we brought the world's first pigeon pea speed breeding protocol. That is very important because this is one of the crop where highly photosensitive, where we have brought the first hybrid, the speed breeding protocol for the pigeon peas. So when we come to crop improvement, the normal duration of the varieties were around 160 to 180 days. ICRISAT bought less than 100 days maturity also. Those we called as a super early or extra early pigeon peas. Then there are more than 20 Pygidium wilt and stolti mosaic disease resistant varieties have been bred. And also when we come to the potential high yielding varieties, the yield gap is around 3.5 ton, because the average yield we can get around 2.25 tons per hectare in varieties and 3 to 3.5 ton for in the hybrids. So there is a huge demand for hybrid to bring this yield gap and also bring the Atmanirbhar pulses in India. The major challenges in this crop is the Phytophthora blight and the dry root rot becoming the major challenges to this crop. And pod borer and fusarium wilt and stolti mosaic disease are these are the age-old disease also associated with this crop. But the fusarium wilt and stolti mosaic virus, most of the lines which we release to the commercial cultivation, they have must have trait, and specifically we breed for these two traits. And more recently, we are also seeing the pod fly impact, which is also we have started screening our material which can tolerate the pod flies. So another abiotic stress constant which is specifically targeting a pigeon pea is the water logging, and water logging followed by Phytophthora becoming the major challenges to this crop in the current era. And drought and heat, specifically the crop grows more than 4 to 5 months, so we need to have specific adoption to drought and heat condition. And the age-old problem associated with this crop is the photopid sensitivity and agronomic doping. That also need to be taken care in, specifically when you breed the hybrids. And the seed shriveling become major challenges when you take the pigeon pea into the post-rainy and summer conditions. So globally, overall, we have the two market segments and the four target product profiles. In first three market in target product profiles, we breed the medium, mid-early, and early duration pigeon varieties. And in the fourth market segment, we specifically breed the hybrids actually. And in ICRISAT, we have a so separate sub-hybrid breeding program, the seed parent program and the restorer program. And we follow a specific breeding schemes to bring the varieties and go for the yield testing. And in all the four market segment, we do a two kind of testing, stage one and stage two testing with national program partners and also the private seed industries. Then we identify the best lines, those will go to the AICRP nomination, and also we do a hybrid parent research consortium coding to give it to the partners. And once it released from the AICRP, then it is goes for the commercialization through AICRP system and also to the private industries. The most important significant achievement for this crop is specifically why we are lagging in this crop is the breeding cycle. Earlier, before speed breeding, we used to take around 12 to 13 years to bring a particular variety because we used to take only one generations per year. So specifically, we put effort to bring the speed breeding where we can do a four generations of per year. So you can see different light intensities and different durations wherein we give specific light intensities to induce flowering and also get the pod at the quickest time. So here we can see the early maturity we can take four generations, and the medium and mid early duration we can take up to three, and long duration we can take up to two. And the publication you can also find in the Nature's Plant Methods. So we have mentioned all the stages. Whoever want to do a speed breeding, they can follow these particular steps in this crop. And more recently, we released this piece of document that is World First Pigeonpea Protocol that is available online and also can be found out at ICRISAT's website. Then now when we come to this specifically to the hybrid pigeon pea, as I told, there are four hybrid released commercially from two from ICRISAT bed material and another two from our national program partner from IIPR Kanpur. But the hybrid recorded up to 30 to 50% yield advantage over the varieties. That is the major important thing we need to notice in this one. But why the hybrid pigeon pea potential parental lines and hybrid for early duration? The major challenges in this particular hybrids is that the CMS breakdown has been noticed in some of the seed production plots once we have the hybrids identified there. Then the hybrid maturity went more than 200 days. Then the irrigation facility required to sustain those hybrids beyond 180 days. Then specifically because of its high vigor for the woody growth, and that makes it difficult to spray, and the damage will be for the specifically for pod borer and pod flies. Then because of its highly photoperiod and thermosensitive parents, the hybrid seed production restricted to only one season. Then the high cost for hybrid seed production incurs. Then purity testing becomes a major challenge because of their photosensitivity and thermosensitivity. Then hybrid seed storage cost added to this one. Then it's become a less net return to the companies. So many of the commercial hybrid release, they could not go beyond this point because of these are some of the major challenges. But what are the existing opportunities available in this crop? As we found, the yield superiority is very high and the CMS availability is there, and resistant to biotic and abiotic stress is already available. Then very good high yield recovery has been observed in hybrids. Then farmer acceptance is also there, and limited public partnership work is there, and there is a huge support of the government of India and many government to this crop, specifically that one. Then how to overcome these specific problems actually? When you take the successful hybrid breeding programs in the world, specifically when you take the maize, palm, sunflower, mustard, and vegetable crops, as a ICRISAT, and I can take the example of palm millet, wherein most of the hybrid release in the commercial world coming from the ICRISAT's bred material. So we have standardized the specifically the hybrid parent research and bringing the more productive parents and more productive hybrids like elite into elite crosses. Sir, we have the required variability for the trait germplasm in pigeon pea. Then hybrid in early durations are available at the moment. Then stable CMS has been identified and standardized in the current breeding program. Then there we have also developed the photo and thermo insensitive parents where you can go for the hybrid seed production in the off season. Then well-defined seed and restore parent traits have been defined in the recent time. Then flower traits amenable to higher cross-pollination has been developed now. Then capping and maturity duration has been also one of the major challenge that we brought into our breeding programs now in our elite lines. Then active participation of the private sector also we are taking now. So involving these one, we can overcome the problems of hybrid seed production. Then another major challenge I produce, because once we can produce the hybrid, but the hybrid seed production is a major challenge. If you taken care of that one, then hybrid can move on to this one. You can see the fall millet and the pigeon pea hybrid we are bringing onto the same table, and we are bringing the parental types like pearl millet where the open pollination is more compared to the earlier our previous varieties. So these kind of hybrid parents and the hybrid can be taken to the field with a more improved on the photosensitivity and the thermo insensitivity and also seed shriveling nature, and we can produce in the off season and also in the summer irrigated conditions to produce the hybrid seed, and the seed cost can be very less compared to the previous ones. So these are some of the our recent varieties which are identified as a best parental lines to breed. This is the we produce in the summer, particularly this is in the field now. This is we produce like ICP 21 one of the best early maturing variety identified, mature in around 120 to 135 days in the summer, and where we can also bring such kind of short nature and amenable to mechanical harvesting kind of parents which can very easily breed for the hybrids. And now we also provide the genotyping platforms, which are like mid density and low density genotyping platform to track the hybrid fertility status, and also the mid density panel to genotype and bring more better hybrids and the hybrid parents in the coming days. Then also we have the wilt and SMD6 plots which are very well developed at ICRISAT. Those we are also using to screen our hybrid parents, where we will be targeting the traits which are economically important to the farmer as well. Then, as I told, more recently we have the waterlogging at the field level, and current breeding program itself, while breeding the parents itself, we are taking care of the parents who should be waterlogging tolerant at both seedling and at the knee height stage, so that the hybrid can withstand that particular waterlogging conditions and also part of the resistance. So bringing these traits. And along with, as I told, the majorly it is a the photo insensitive becomes the one of the important trait when we go for the hybrid breeding. So what we made is we made the variety the breeding lines which we are bringing in the current hybrid breeding program. So they can withstand up to 40 to 43 degrees centigrade in the summer, and the production can be taken if you plant them in early January and in specifically in India, where you can take up to one generation within the 3.5 to 4 months and produce a good amount of seeds with using the improved pigeon pea lines. And for seed shriveling, we just started the phenotyping for seed shriveling in pigeon pea, because this was also we thought one of the major challenge when you bring your pigeon pea from rainy season to the post rainy and summer conditions. So that we standardized the protocol method and also identified some of the best hybrid parents which can overcome the seed shriveling nature, and we can produce the best hybrid commercial hybrids. So we brought this particular machinery to screen our best promising material and also identify the best hybrid combinations. Then we also identified many number of restorers coming from Havelite material, starting from adopted material from India and also from the Eastern Southern Africa. So we classified our restorers and maintainers into different groups, and we heterotic combinations we are making in the current breeding program. So this is the maintainer pool, wherein we are also diversifying our B line pool and the R line pool specifically to bring this best heterotic combinations. Then, as I told in the recent times, we also standardize what are our best parental lines, the best parental traits, specifically for the seed parent traits like stable sterility and open pollination, photoinsensitive, heat tolerance, non-shriveling nature, and the wilt resistance, SMD resistance, good general combining ability, and the high seed yield in the female parents. Then cold tolerant, if anything, if you want to go in the post rainy season, and open flower, that is the what we are specifically bringing along with this trait, and plant height of 100 to 130 centimeter, where we can go for specifically mechanical harvesting type. Then we are also bringing annuality, because as the crop is perennial in nature, as long as you give water, it also start giving flowering. Then it has to stop at specific period of time. So we also brought a specific trait called annuality in our hybrid parent, so we can stop its maturity at particular time of point time. And I can also see the open pollination of our new females, which can assure at least 80 to 90% of the cross pollination among themselves. Then for restore appearance also we brought a strategy. Those also again photoinsensitive, heat tolerant, non-heat shriveling, wilt SMD resistance, then high yielding good GCA open flower, then high pollen production. That trait again it is a must-have trait for the restore parent. Then non-determinate growth habit and plant height up again 130 to 150 centimeter just to pollinate them properly during the hybrid seed production plots. Then this is one of the important trait. Also, we are bringing the mapping maturity capping. Specifically, we identified a germplasm set where we can you can see two different here. The one which is having the annuality trait and one which is having continuously growth of green stage. That what is the help of this particular trait is we can bring the uniform maturity, mechanical harvesting, then minimum yield loss, better harvest index, nutrient efficiency, and market prediction can be done with this particular trait. Just bringing this trait can help you many number of trait and the problems associated with those previous hybrid breeding programs. Then now we have the commercial lines which identified having the perennial annuality in nature, and those we also brought in our hybrid parents. So these are our some of the breeding schemes where we are using for bringing a elite, very elite breeding material and bringing them in within the 3 years of time. So new every year we do some 200 new parental line development both on the B line and also on the A line using these particular schemes through speed breeding. And then, as I told, Government of India has supported us in bringing a new Pigeonpea hybrids that is specifically early maturing hybrid with involving 13 states and 13 state agriculture universities and also the private industries, wherein we brainstorm the hybrid Pigeonpea, how that to be taken shape in India and also across the world. Specifically, we concentrating on A2, A4 CMS in the early maturity for south and central zones and also the NEPZ zone. Then key traits defined for the both hybrid seed parent. Then they also decided to have ICRISAT lead the parental development along with the IAPR collaboration. Then parental lines which are post adapted to post rainy and summer irrigated conditions for better hybrid seed production. Then multi-environmental testing through AICRP center in south central and NEPZ zone. Then FLD of VT2, that is frontline demonstration of the hybrid which are in AHT2 in 1 year before the specific release, and where the private industry can also take those and test and give it to the give the result, and they can also take it forward. Then what is the current status of Pigeonpea hybrid? We have the early maturing germplasm and advanced breeding material at ICRISAT where we can take even from 90 days to 180 days. Then we also have the stable thermo and photoinsensitive lines. Then seed production in the off season possible for the current breeding lines are the hybrid seed parents which we brought now. So we can produce at any season of the year. So they are highly photosensitive, and you can see them here as well. This is the off-season cultivation of pigeon pea. Then now we also brought the heat tolerance in our hybrid seed parents. Then we brought the amenable to cross pollination, the open pollination system. Uh, and also we brought the well-defined seed and restore parents and standardized the seed production in the off-season work in progress from this year. And probably next year we'll have the better hybrid combinations which you can produce in the farmer field. But only thing is that we have the active participation of the private seed sector is limited. So by here I request if any private colleagues are joining, please visit the ICRISAT and see our current hybrid program in the current. Now also we are doing the seed production field at ICRISAT, so they can visit and see how they can incorporate here. Then why we're bringing short duration hybrid means this is a greater demand from the industry and also farmers and us because of the climate change issues. Then also the stable cytoplasmic cystic maturity can be exploited from here because of the longer maturity duration. This also have problems with the CMS instability. Then we can have the shorter breeding cycle, at least 2 seasons per year in the field and 4 seasons per year in the speed breeding. And high heterosis up to 40% has been observed in our previous hybrids and the current hybrid breeding program. And very easy to grow out the test, and photoinsensitive is in hybrid seed production and suitable for non-traditional diverse cropping systems around the world. So this is our the current breeding program. You can see the dot pigeon pea lines which is having a number of pods. Those were now converted as a female line, specifically adapted to the current climatic zones across India and South America, Australia, and other countries, where you can go for this dog kind of test. So now currently in the breeding program, we have several seed parents of around 200 lines, that is female line. Then diverse restorers, more than 50. Then promising hybrids, we have more than 700, where anybody interested in licensing, they can take the hybrid. Then current breeding program, we are doing around 7,000 new test crosses per year. So to bring most good hybrids to the market. Then yield, we are targeting around more than 1.5 tons per hectare. Then seed production, we are targeting in the post-rainy and summer condition. And also the heat tolerance, photoinsensitivity, thermosensitivity, hybrid duration, and the hybrids. So we are taking care as one of the must-have traits in them. Then hybrids in the ICRP testing, we have the HT1 around these two hybrids are in the current stage of testing, and many hybrids which are around the testing at ICRISAT side, they can visit and also take into the private seed industries. So ICRISAT is a unique consortium of hybrid seed parents that we called as HPRC. This focus on specifically on the parents and restorer parents, research on seed and restorer parent. And we also develop efficient seed production hybrid parents for the different agroecologies around the world and showcasing the breeding material to seed companies worldwide and also for the NAS partner and sharing lines with the partners. So, but this the private seed industry has to have the membership with the ICRISAT. Specifically, we have two kind: promotional membership and primary membership. Promotional membership can take up to a limited number of lines, but primary membership can take to up to 300 lines per year in a 2 years of cycle. So, anybody interested, you can contact me through my email prakash.gangashetty@icrisat.org. So these are our partners, specifically who work across the globe for different kind of projects. And thank you for this opportunity. Thank you again. Dr. Reddy?
Thanks, Dr. Gangashetty. We will go to the questions now.
Yeah.
So there is a question which is, what is the hybrid seed market value in India?
So hybrid seed market, specifically when you take the varieties, we take around, this is the certified seed around 130 rupees per kg. I think for hybrid it is around 250 rupees per kg.
Okay.
Yeah.
The next question is, any GMS source are available in ICRISAT?
Yes, we have available GMS sources, but we are working mostly on the hybrid CMS based hybrids actually in the current breeding program.
Thank you. The next question is, what is the heterosis percent in Pigeonpea?
The heterosis percentage varies from around 40% to around 55 to 60%.
Thank you. I think moving on to the next question. We see some questions in the chat. One of the question is, what were the challenges of speed breeding in comparison to conventional breeding? And which type of breeding method remain more beneficial?
Specifically this crop, because it's a highly photosensitive nature and also the thermosensitive nature, the crop has been restricted to only one season, that is the rainy season across the globe. So, and also if you take only one season, the genetic gain will be very less because the cycle time is inversely proportional to uh, the cycle time is inversely proportional to genetic gain. So we must have at least more than 2 generations per year. So that's why we had a specific challenge of bringing the new varieties within a shorter period of time. That was not possible. And with the speed breeding, we can bring the varieties within quicker time. And now the cycle time is only 3 years in the hybrid breeding program for us now. And special breeding method, we don't use anything like that, but we use the single seed descent method that was followed in our current breeding pipelines as well.
Thank you. The next question is, what is hybrid seed production per kg? Seed rate in terms of hybrid versus variety per acre. I think these are two different questions. So first
Yeah.
one is, what is
For
hybrid
varieties,
production?
for varieties, it is 6 kg per acre actually. And almost around the recommended is around 16 to 20 kg per hectare, but the hybrid is only 2 kg per acre, I think. Yeah.
Thanks. The next question, how is the tolerance level to pod borer?
We can expect up to 60% of tolerance to the pod borer.
And we have one more question. Any speed breeding protocol support available for vegetables from ICRISAT?
Yes, I think if anybody interested, you can contact us. So we'll be helping with in these two things actually. The first thing is to standardize the speed breeding protocol. If they have standardized speed breeding protocol, they can use our facility to do the advance of generation. And second thing is advancing generations in our speed breeding facility. So they can contact for both.
Okay. And we have the next question here, which is hybrid seed production per kg. What is the cost? I believe that's the question.
So that we are working out now, but the hybrid seed we can get up to around, with the current lines, we can get up to around 1,000 kg per hectare.
Okay. Moving to the next question. Did you apply photoperiod modification or extension in your speed breeding protocols?
Actually, we did we did not do anything photoperiod modification or extension. We use the crop duration model actually, that how the duration of pigeon pea takes place in the rainy season starting from June to December. Then that we model into our speed breeding facility.
Okay, thank you.
Yeah.
Maybe we will wait one more minute for any. Okay, we have another question here. Can you describe more about the optimum conditions like temperature, light intensity, and humidity, as well as suitable setup provided while speed breeding?
Yeah. I think those details you can find out in the paper. That paper has been already published and it is openly available in the online as well.
Okay, thank you.
Because it needs a special presentation for specifically for speed breeding itself, because it's a new topic and everybody in that one. So I just shown the glimpses of how the pigeon pea breeding we do with the speed breeding here.
Sure, yeah, definitely. I think it is
Yeah.
a lot of information in one question. So,
One
yes.
question, yeah.
Um, this is all the questions we have. So maybe we can wait for one more minute to see if there are additional questions before we move to the next presenter.
Yeah.
Okay, next question. We got another question. Does germplasm of vegetables available at ICRISAT for material exchange?
Actually, I think if anybody knows ICRISAT, we works only on 6 mandate crops, specifically pearl millet, sorghum, and finger millet in cereals, groundnut, pigeon pea, and chickpea in the pulses. So we can only give the germplasm sources for these 6 crops. We don't do any vegetable breeding here at ICRISAT.
Going to the next question. Any hotspot locations? Um, have any hotspot locations for fusarium wilt been identified?
Yeah, there are 15 hotspot locations. Those are identified by the AICRP system. Those we use for the screening of our materials as well.
Thank you. The next question is, I believe it should be, do you have resistance for fusarium wilt and sterility mosaic virus?
Yes, we have a durable resistance to both wilt and stealthy mosaic disease, and those two are must-have traits. Any line which is coming to commercial, it will have both the resistant genes in them.
Okay. Our next question here is, did you attempt double haploid in pigeon peas?
Double haploid protocol we are standardizing actually. We are 90% through now. Specifically, I think it may be another 6 months we are coming with the double haploid in pigeon pea. And probably we'll bring a protocol and also see how commercially we can use those DH for the rapid cycle genomic selections.
Okay. Was it in vivo or is it in vitro DH? Is a follow-up question that is coming.
That is, I think, we'll describe in the paper. They have to see that one.
Okay, I think we don't see any further questions now. We can definitely get back once if there are additional questions for Dr. Gangashetty. But for now, I think thank you very much, Dr. Gangashetty. We will move to the next speaker. Thank you.
Yeah. Thank you, Lata. I think my final question is, do I need to stay in this webinar or I can exit because I have the foundation day at ICRISAT today. So I need to go that for function.
Mm, I think you can leave Dr. Gangashetty. Any questions that come through for you, we will be sharing it. APSA Secretariat will share with you, so
Yes.
you can answer them on email, and then we can share back with the relevant participants.
Yeah, thank you. Thank you. Thank you for this opportunity and wish you all the best.
Thank you very much.
Thank you.
So our next speaker for today is Dr. Manoj S. Phalak. He is an accomplished plant breeder and molecular biologist with over 27 years of expertise in conventional and molecular breeding. He holds a PhD in molecular breeding, specializing in disease resistance in rice through marker-assisted selection. Dr. Phalak pioneered the development and commercialization of genetic male sterility-based hybrids in dolichos beans and cowpea. He has spearheaded numerous research initiatives, authored several publications, and played a key role in regulatory affairs related to GM crops, contributing significantly to advancements in crop improvement and hybrid seed technology. Today, he will be talking to us on the topic of development and successful commercialization of genetic male sterility system in dolichos beans and cowpea for hybrid seed production. So with that, I will hand over to Dr. Manoj S. Phalak and invite him to share his presentation and take us through the topic today. Thank you.
Thank you, Dr. Lata. Am I audible?
Yes, we can hear you. Yes.
Yeah. Please share the presentation. Yes. This one. Is it full screen?
Yes, we can see your screen.
Yeah. So, good morning, good afternoon, and good evening to all the scientists and people who have joined to this webinar. Thank you very much, Dr. Gangashetty, for taking a very good review of Pigeonpea hybrid breeding program in India. Actually, I have started my career with Pigeonpea breeding, and I know the problems in hybrid Pigeonpea development and the problems we have faced in developing a very good hybrid in Pigeonpea. Keeping that experience in mind, and also the intricacies of developing hybrid in leguminous crop, that was in my back of mind. And again, I have started breeding in cowpea and beans in 2012. I was earlier working on that, but because of another responsibilities, it was handed over to another breeder. In 2011-12, I have started again the breeding on dolichos beans and cowpea. When I have started this program, uh, then I come to notice some problems in this particular crop that we will discuss in this presentation. My presentation is very small, very clear. We want to discuss only about hybridization hybrid programs of cow and beans and development of GMS systems in these two crops. So before we start on actual presentation, let me tell you about my company. And it is a proud moment for me that my company is celebrating 50 years of its completion. And we proudly say that Ankur Seed is a research-based company and we always believe in innovative research. So my company is founded in 1976, and we have a rich experience in many crops, particularly we have developed a lot of germplasm in many crops. We have registered germplasm. We have registered many hybrids in agri system. So, driven by continuous innovations in every field of activity like research, production, processing, quality, and marketing, we have a means full-fledged company having all sections of plant breeding, including research in almost all sectors like genomic assisted breeding, marker assisted breeding, then development of double hybrid technology in many crops. So there is a very good support system to uh, breeding in Ankur seed, especially given by the molecular breeding team. So we have recognized by our research is recognized by Department of Science and Technology, Industrial Research, Government of India. Then we win national award from Government of India for best in-house R&D achievements. So these are some of the things. Before we start, we can talk about Ankur seeds because people from many countries are must be listening to this webinar. So the basic information about Ankur seed they must be knowing. So this is our portfolio. Our major crops are cotton, paddy, wheat, and maize. These are our suppose this is the major revenue contributing crops to our company. Then pearl millet, pigeon pea. Pigeon pea we are also working very good, and we are selling quite a large quantum of pigeon pea varieties. We are talking with Dr. Gangashetty for pigeon pea hybrids also. Then major vegetable crops, tomato, hot pepper, okra, brinjal, cucumber, bitter gourd, and rich gourd. And last you can see beans and cowpea. Now this last cornered crop I want to bring in the top. So this is actually the revenue generated by this crop should be means they should surpass the Solanaceae crop. That is my aim. So let us see what happens. So this is all about Ankur seed. I wanted to talk briefly with the audience. So let us come to our topic. How this development of hybrid in cowpea and beans has started. So when I have taken these crops for breeding, I come to know that even for the genotypic development program, we develop F1 hybrids from two different parents, and then we segregate them to get a new line. This is a normal breeding protocol we follow in our. So everyone follows that. But even to get a normal means F1 for genotype development, it is difficult in this leguminous crop. Many a times you always get female, and it is difficult to get true F1 in your, and there is a very big problem, and a lot of labors are required. So I thought we should have some solution to this problem. So I have devised a mechanism which has helped me to develop emasculation-based hybrids, which is very efficient cross-pollination. And inspired by that success, then I started thinking further. So developed a highly efficient cross-pollination method producing 99% genetically pure F1 seed in cowpea, which was planted in summer 2012 at Nagpur. This is a breakthrough actually. Before I could come to GMS and development of hybrid, this was basically a thing which has driven me towards the development of hybrid. So discovering strong heterosis and climate resilient traits in EMS-based hybrids, inspiring the idea of commercial hybrids in cowpea. Uh, After developing this emasculation-based hybrid, and I have given these habits for checking in the laboratory to just see what is the genetic purity of this hybrid based on SSR primers. And when the laboratory told me all of you have seed what you are given. They are 100%, or not 100 actually. That's 99% genetically pure. I can say 100% genetically pure. So that has actually a good news for me. And to advance the generation early, I have planted that material in summer season. And if you know the summer of Vidarbha region and Nagpur center of India, it's a very harsh climatic condition in this region. In May, the temperature here goes beyond 47 degrees centigrade. And if you don't plant a cowpea variety in the month of May or February, you could not get a good yield out of cowpea varieties. So, general recommendation for cultivation of cowpea in Vidarbha is early January and early February. I have planted this material in the month of say late February. That time it was not the target. Just I wanted to advance the generation. But to my surprise, I could see the heterosis, the level of heterosis, the trait which are highly resilient to climate. Uh, that has means heterosis levels were really amazing. So discovered a strong heterosis and climate resilient traits in the image-based hybrids, inspiring the idea of commercial hybrids in coffee. Applied the same strategy to Indian beans to create commercial F1 hybrids. So I was also working on the Dolichos beans. So I have developed some EMS-based hybrids, and that also I wanted to check for its heterosis. Meanwhile, inspired by this high level of heterosis, I started searching for the literature and let us see, see if someone has reported milk sterility systems in cowpea and beans. So I came across one paper published by IITA long back, say in the 1980s and somewhere. So I contacted IITA through emails. I have written four emails to IITA, but I could not get any response from IITA. So I have decided to start my own mutation breeding program in coffee. So I have started mutation breeding program in coffee and given 2, 3 treatments like 20 KR, 30 KR, and 40 KR, and I have initiated the program. So this slide you can see, this is the slide from May summer 2012. Last 13 years, I have not changed this slide. It is the even the color of the bars is the same. Before 13 years, I presented this slide in my annual review meeting, and the same slide I am presenting here today also. You can see VUH means hybrids, and Sweta was a popular variety at that time. YB7 was very popular variety at that time. VUH 130, you can see. Then Hari is my variety. I have developed this variety. And then another variety. Ketaki is also one of our variety actually. This is another hybrid, VUH 124. Kashi Kanchan is a very popular variety from the government system in India. That is VR Varanasi. Then this 198 and Gomti and VU5. Some of the hybrids have shown less yield because they are dwarf hybrid actually. So that's why. And this very high heterosis hybrid, they are and viney hybrids, means the indeterminate type of hybrid and determinate type of hybrid. Here, most important thing is tolerance to high temperature and biomass production in a very climatic condition. That is one of the very important factor which is prominently noticed in this particular trial. So this is a very old slide. Actually, it is completed 13 years now. So I have started program in cowpea, but I was always wondering, even in cowpea, the flower size is bigger. Emasculation-based hybrids making is somehow possible. But what about Indian beans? Indian beans has very small flower size, and thousands of flowers are there, on one plant. It is impossible to even think about hybrids in Indian beans without sterility. So I am highly influenced by one novel, The Alchemist, that Paulo Coelho, who says when you want something, all the universe conspires in helping you to achieve it. And the same thing happened with me. In the subsequent Kharif generation, when I was purifying one of my variety, now it is in the market on the name of Ritu, and I have planted 40 plants per progeny, and I have planted around 100 progenies. One of that progeny has segregated, and I have seen 4 plants which are sterile, and another plants are fertile. So on the same plants, I have taken A into B class because I was very efficient in cross pollination mechanism. So I have started making A into B crosses, means sterile into fertile process, and I have started maintaining that. And because it is following almost 3:1 ratio, means 75% fertile plants and 25% sterile plants, I was always almost convinced that is a single gene recessive mutation is there, and which can help me to generate F1s in Indian beans. So now I have a running program in cowpea, which is means mutation through mutation, and I got a natural mutation in Indian beans, which is there in my field. So now, I mean, before I could get a GMS system in cowpea, I can standardize, I can and use this Indian bean GMS sterile plants in this crossing program. So development of GMS in cowpea and discovery of GMS system in Indian beans. So gamma ray mutation 30 KR yielded a desired results. In the M2 generation, I identified 3 plant group progenies with sterile plants. One progeny was selected and multiplied as a newly developed GMS in cowpea. Here also, I am fortunate enough to get a progeny without any morphological abnormalities, having a fully female fertility, and not disturbing any of the agronomical characters. Another 3 progenies I have rejected, another 2 progenies I have rejected, and this progeny I have finalized as a new GMS system. I have tested this maintained population in different locations, in different temperature conditions, for checking the breakdown of this sterility, and I found that this sterility is highly stable, it does not break, and can be used in a commercial hybrid breeding program. So I have newly discovered single gene recessive male sterile mutant in Indian beans, was multiplied and used for producing the test tablets. Discovered another independent GMS system in Indian beans in 2019. This is another thing. Already I have one GMS system which is there in the place. In 2019 also, I have discovered another GMS system in Indian beans, and that in GMS system is also there in my germplasm, and I have tested it through allele test, and established that these 2 systems are independently governed by 2 recessive genes. Means the GMS system which is discovered in 2012, we have named it as a GMS1, and this GMS system which is discovered in 2019, we have named it as a GMS2. So these two GMS systems are it is established that these 2 GMS systems are really different, and they are governed by 2 different genes. So this is what I wanted to tell. Then this thing we have published in our internal publication, that we publish our one of our not journal, actually it is a sort of bulletin that's called Achiever, and whatever achievements are been done in Ankur Seeds, we just document that achievements in this particular bulletin, and this becomes our internal record also. So you can see this photograph I have taken on 12th of December 2012. So this is actually the bean, Indian beans photograph. And based on this, I have released world's first GMS-based hybrids in Indian beans. So we have released 2 hybrids, that is First, Dolly. Dolly name has been kept because it's a Dolichos beans. And another is a flat segment hybrid, that is DLH 427, which is also very highly popular now in India. So this is the cowpea flower. I have shown earlier flower was the Indian bean flower. This is the cowpea flower. You can see in the sterile flower, the anthers are translucent, and the fertile flower anthers are full with the pollen grains, and they are yellowish in color. And you can see there is a clear-cut difference and identification of sterile and fertile plant based on the flower morphology or pollen morphology. It's a very simple job. It does not take more than 10 seconds, 20 seconds for a trained labor. So this is cytological studies we have conducted. There is no pollen formation in sterile flower, and fertile flowers are abundant with the pollens. So after confirming the production system, after confirming the performance of hybrid in different climatic zones of India, after confirming the heterosis, and after getting the very good remarks from the end user, that is farmer, we have communicated this to the media as well as to the other channels. So this is the news we have given in the media for Indian beans. And our sister concern company, that Dharti Agrochemicals, Dharti Agrochemicals has started marketing cowpea hybrids. And this news also we have given in the media. We have waited for around 4 years before giving actually news in the media, because we just wanted to become a means confirm that there should not be there is no problem in GMS system, there is no problem in heterosis, and it is beneficial to the farmer. It is actually doubling the income of the farmer. That is what we wanted to confirm, and then only we have published this news. So this is the world first hybrid series, and it is marketed by our partner, it's a sister concern, Dharti Agrochemicals Private Limited. And bubbly is a dark green material, means it's a medium long, and Shirley is also medium long, and it's a light green. And Purvaja, it's a purple hybrid, and it's a medium long. So these three hybrids we have first released on the GMS system we have developed. So let us talk about cowpea hybrids and why it is beneficial to the farmer, and why farmer should purchase such a costly such a hybrid in the cowpeas. Means in the regular season, we can expect around 100% heterosis over the best available varieties in market. We have means Ankur is a leader in India in a varietal segment also in coffee. But still on our varieties, hybrids are giving 100% heterosis in regular season. And the most important and convincing thing is the sowing windows, which is not accessible to the farmers, means late March and March to say April, May, which is not accessible to farmer because of high temperatures. So nowadays, farmers are growing cowpea of funds in February, March, April, May, June, July, and getting very good results out of this because of its highly thermotolerant nature. Around 200% to 250% heterosis we are getting in summer season, and that is actually changed the way of coffee cultivation in India. This is becoming a very good income source for the marginal farmers, particularly because the people who have less land and they want to more money out of that small land. They have opted this option very fast, and now it has become a very popular thing in India. So in off season, we are getting around 200 to 250% heterosis. So triple the yield. And beautiful thing is, if you compare it with varieties and compare the early pickings, almost triple the yield than the varieties. And that if you see the market dynamics in market, when you bring your produce early in the market, you get more profit. It is not about the yield always, it is about the profit. So farmers are getting more profit by planting these hybrids. So we have developed thermotolerant, photoinsensitive hybrids in both cowpea and Indian beans, resistant to the golden mosaic bean virus. These hybrids are highly resistant to the golden bean mosaic virus, which is a big problem in India. Another problem is there in India, it's slowly emerging, that is groundnut bud necrosis virus coming in coffee. But our hybrids are resistant to that particular virus also. So excellent transport quality, ensuring freshness and shelf life. So nowadays, transport mechanisms in India is very good. The roads are very nice. So even transporting 1,000 kilometers to 1,500 kilometers is not a problem in India nowadays. So you can target any market which is suitable to you by cultivating the coffee hybrids in any part of India. So that is I can given a flexibility to farmers for planting new crops. Farmers are getting higher profitability per unit area. That is actually the beauty of these hybrids. Uh, in from 1 acre, people are getting really good benefit than the cash crops, other product cash crop or your field crops. So they are slowly, means particularly marginal farmers who have less land, they are turning towards this coffee and beans habits. So just for I have not much data presented in this particular presentation, but you can see summer yield versus the kharif yield. If the Ketki, the first bar graph, the blue graph represents the summer yield, and another graph represents the normal season crop. If you compare with the variety against the hybrids, you can see there is a lot of heterosis, and this is from our field. And if you know, on our field, we just do not carry trials for a long period of time. On farmers field, actually, we are getting far better results than this data. And farmers are telling us that they are getting very high yields as compared to the varieties. So this actually this data is not means farmers are getting better results than this. Here also you can see around 100% heterosis, 30-40% heterosis, but farmers are getting really better yield than this. So we have two segments. One segment is a medium-long segment where I have shown you three materials, that is bubbly, Shirley, and Purvaja. This is in the medium-long, that means 30 to 35 centimeter long pod. And recently we have launched extra long segment hybrids. That hybrids are 45% to 50 centimeter long pod. Actually, this will be a very big achievement, because if we see the yard long beans are quite susceptible to high temperatures, and we could not get optimal yield if the temperature goes beyond 40 degrees centigrade. So this particular extra long segment hybrids, they are giving excellent yields in high temperature regions also, and giving a very high thermotolerance. Rest of the characters like bean mosaic virus resistance and adaptability, absolutely no problem. These two hybrids we have launched in this segment. Here you can see Ankur XXL, here one, and there is another Ankur XXL also. This is from two regions actually. This data is from two different regions. So you can see the yield differences. Against Imperial is our variety in the Adlong segment, which is the purple in color. Then VU 777 is another variety which is launched by Ankur Seeds in the Yardlong segment. Ganga is also our variety. It is a long segment and is a dark green material. As compared to varieties, if you see the yield levels of hybrids, means amazing. There is a vast difference between the varieties and hybrids. Actually, we have not also expected this, but really this is amazing, and we are getting a very good heterosis in cowpea and bean. So this is the cowpea habit series we have given in the market. Already we have talked about their peculiarities, and just to revise, bubbly is the part of world first cowpea habit series. Viney, vigorous growth and high yields. Staking is must. You see, to get the optimal yield, we recommend that farmers should take this habits on staking, and the plant to plant distance might be 60 centimeter to 90 centimeter, and the row to row distance must be around say 120 centimeter to 150 centimeters. So resistant to golden bean mosaic virus, attractive green shiny medium long pods, that is 32 to 35 centimeter long, and hybrid comes to first picking in just 48 to 55 days after sowing. Uh, Good taste, keeping quality, suitable for long distance transport, etc. This is actually the peculiar traits which is required by farmer, and that all things are there in this hybrid. So it has become a very popular among the farmers, and spreading very fast in India. So surely the same thing you can see. Then the Purbujas, the characters are almost similar, only the color is different. This is a long segment, this is actually a challenge, because creating a hybrid uh, almost a yard long type of a pod is a really challenging job, because if we can do this, we can bring a revolution in a yard long segment. So, and this is successfully done. We have introduced two hybrids in a market. Our Dharti Agrochemicals is selling DDGL 45 in the dark green segment, and Ankur is selling Ankur XXL, this green segment hybrid. So these are the two hybrids right now we are marketing. Ankur Celebrity also there in the market. So XXL means extra long. Extra large it is actually, but I have taken this as a extra long. So Ankur XXL represents 45 to 50 centimeter segment, and it's a green type of material. Becoming very popular among, in a short duration, it is becoming popular among the farmers. So in Indian beans also, the first hybrid, Ankur Dolly, you can see it is a round pot with a small sort of constriction. Then DLH 867, it is recently launched before 2 years. Is highly resistant to golden bean mosaic virus, thermotolerant, and photoinsensitive. This particular material is very popular among the farmers, and farmers are waiting for this material. So this then in a flat segment we have DLH 427. This is also a golden bean mosaic resistant hybrid, high yielding, photo insensitive, thermotolerant. So this is the same thing I have written here. So thank you very much, and this is what I wanted to narrate. Uh, Successful commercialization of hybrids in leguminosae. We have seen a case of Pigeonpea. They are about to success, but it is farmers have some reservations to adopt that particular hybrid because of the problems in CGMS system. But keeping that experience in mind, I was also skeptical whether this particular GMS will work, whether it will remain stable in production areas or not. That's all the things we have checked, and we come to the conclusion that the hybrid revolution has started in cowpea and Indian beans. So thank you very much.
Thank you, Dr. Manoj Phalak. We can go to the questions for you. So the first question here is, did you identify 3 sterile plants in F1 or F2?
No. Yeah, in F2 definitely, because it is a segregation. So F2 you will get the sterile plants, but F1 no, 100% fertile plants are there.
Next question. In percentage, how much percent the possibility to obtain GMS progenies using gamma-based mutation? Could you tell more about this
Yeah.
from first attempt until achieving the favorable one?
Yeah, in my case, I told you in my M2, I have planted around 300 plant root progenies, and it is almost 2 acres of field. Out of that 300 progenies, I get around three progenies, which are shown with the sterile plants. But two progenies I have not liked much. One progeny I have finalized. So it depends. Actually, it is a sort of luck also. So it is not a certain mutation breeding is not a certain thing. You have to try and see.
Thank you. Next question. How did you produce hybrid cowpea long pod? Is that using GMS?
Yeah, it's GMS particularly. GMS, all I have in this particular presentation, I just talked about the hybrids and GMS based hybrids only.
Next question. What could be the cost of seed production per kg of seeds in cowpea and in dolichos?
Yeah, it's a good proposition. We can produce a lot of hybrid seed without any problem. But because I am from private institute, this is the confidential information. I cannot share this on this program.
Next question. What is the GMS source used to develop GMS lines?
This is my own sources. That is what this presentation is about. One GMS source is I have developed through mutation breeding, and another in Indian beans. I have found it's a spontaneous mutation in one of my breeding program, and that particular thing I have picked up, and yeah, that is the original sources of Ankur seeds.
Thanks. Next question is, in hybrid seed production plot, any technique available to identify male fertile plants in seedling stage?
Uh, Not actually. You can develop markers, but that is not feasible because bringing samples from the production field to the laboratory and again giving back the results to the production field is not feasible. But I have already told, when you see to the flower in just 5 to 10 seconds, you can make out whether the plant is sterile or fertile. So the laborers are quite well trained. They identify the sterile plant and fertile plant, and 50% roguing of fertile plants is very easy. They are now used to it, and they are happy with the production system also. No problem.
Okay. The next one here is how your referred independent GMS system differ from other GMS system.
Yeah, this is a classical breeding allelism test. You cross these two GMS systems together and make out they are segregating 15:1 duplicate gene action. So that is a classical breeding. Through classical breeding only I have made it, and yeah, it is clear.
Thanks. Next one here is how is the pollination being done in seed production?
Yeah, it's a hand pollination only. We have trained our peoples for that, and it's very efficient.
Okay. Next, how much seeds can be produced from 1 acre area?
Yeah, I can talk about the plants. You can calculate on acres. Uh, Anywhere between 100 grams to 200 gram per plant in Indian beans as well as in cowpea. The hybrid seed can be produced. Even 250 grams. Some people have produced up to 250 grams.
Okay. The next question, do you use any markers for identifying GMS plants?
We have not yet developed GMS markers for this, but we are in process to develop markers for the GMS system. Yeah, but I feel the systems are quite standardized. For further development, definitely we'll use markers. But right now, the things are okay.
Okay. Next question here is how stable is cowpea hybrid series like the Ankur dash dash dash? How is the purity?
100%. That is the beauty. 100% genetic purity, and the characters what we have talked about uh, means resistance to viruses, heterosis, and that's why it is becoming popular among the farmers. Otherwise, farmers will not adapt. Farmers are very clever.
Next question. Did you get significant yield increase by cowpea long pod hybrid compared to pure line or RIL?
Yes, I already shown that slide. There actually in long pod, the heterosis is quite evident because the long pod, if a yard long particularly, it's a quite means not susceptible, but they are not withstanding the high temperatures. If you plant the long pod hybrids in means off season particularly, farmers are getting a very good heterosis over the normal varieties.
Next, is there any thermosensitive reaction which can break the male sterility?
Already talked in my presentation. I have tested all these GMS in different climatic zones, different temperatures, and first we confirm that this particular GMS are highly stable and means what we are using. They are good. No sterility broken. In second GMS system, sometime in thousand or something, I found one or two plants which are a very low level of fertile tolerancee, but it is okay for production. But in the first system, absolutely fine.
Okay. Next question here. What are the most commonly used breeding methods for improving legume crops?
Yeah, that's we generally follow the pedigree breeding method and means magic populations, combining all the good alleles, different methods for combining all the good alleles in one inbred line. That we all people do that. But more important is thermotolerance, virus resistance, and high yields. That has to be there in your lines.
Yeah. Okay, one last question. I think we can take this. Which season is the most ideal one for commercial seed production?
Yeah, it's a June, July, August, September. That's good in India.
Okay. I think participants can continue to add their questions. There's one last question. I think after this, we will request Dr. Manoj to answer them in the chat. So I will just ask this last question. How
Yeah.
is the resistance to disease like rust or anthracnose compared to open pollinated?
Yeah, rust and anthracnose are not of regular occurrence in India, but still we could once we found that reaction of rust. For rust, the habits are quite good. Anthracnose we could not see. We need to check for anthracnose.
Thank you very much, Dr. Manoj. You can stay and we will, get more questions, which we will circulate back to you and try and get the answers. For now, I think we will move to our next speaker. Thank you very much for the nice.
Thank you very much. Thank you, APSA, for giving me this elite platform for talking with the people. Thank you very much. Thank you.
Thank you. Our next speaker for today is Dr. Prakit Somta. He is a distinguished faculty member in the Department of Agronomy at Kasetsart University, Thailand. He earned his PhD in plant breeding in 2005 and his BSc in agriculture with first class honors in 2000, both from Kasetsart University. His expertise lies in the genetics resources, and breeding of legume crops, particularly mung bean and soybean. In recognition of his contributions, he was awarded the Outstanding Plant Breeder of the Plant Breeding and Multiplication Association of Thailand in 2019. Today, he will be presenting the topic YLB Vegetable Cowpea Public Research Project. So this crop is grown on over 300,000 hectares in China and about 20,000 hectares each in India and in Thailand. So although it is an important vegetable legume crop of Southeast Asia and China, there are not many public breeding programs for this crop. And the Thailand breeding program, the traits of focus are fresh pod yield, eating and cooking qualities, disease resistance, and heat tolerance. So I request Dr. Prakit to take it forward and share with us his presentation and the talk for today. Dr. Prakit, over to you. Dr. Pratik, we can see your slides. But we don't hear your audio.
Okay, can you hear me?
Yes, now we can hear you.
Okay. Thank you for the introduction. Today I will talk on the topic of yard long bean vegetable coffee breeding.
Hi, Dr. Prakit.
Yes.
I'm not sure if you can open your camera as well.
My camera.
Yes, so we can see you too.
Okay.
Great, we can see you now.
Okay.
Thank you very much.
Okay,
Please
okay.
proceed.
Okay. My topic today is yard long bean or vegetable coffee public research project. Okay, cowpea, I think it's well known. Cowpea is an important legume crops of Africa and Asia. In Africa, the African people, the people growing the grain cowpea, which is Vigna angulata sub cultivar group angulata. But in Asia, the Asian people, especially in Southeast Asia and China, we people eating the vegetable cowpea or the yam long bean, that is the cultivar group Sesquip fedalis. The yam long bean or the vegetable cowpea, the pot of the yam long bean is quite long. Sometimes may reach about 100 centimeters. And we consume it as vegetable crops. It's really popular in Southeast Asia and China. We produce year round in every seasons. However, compared to the grain cowpea, the yam long bean or vegetable cowpea is more susceptible to insect and disease. In this slide, I show the photo of some dish that has that's prepared from cowpea or has a cowpea as an ingredients. You can see we can use it as a soup. We stir fry it, and we use it as a side dish also. Sometimes we use it as a salad. And in this case, and sometimes we eat it with the vegetable, with the noodle. You can see this is the field production of the farmer production of the yam long bean in Thailand and in Southeast Asia. The farmers harvest the yam long bean starting from about 45 to 50 days they can pick the pot up to 4 times, maybe to maybe 5 days, or every 5 or 7 days we can harvest. For the breeding of the young long bean, most of the young long bean breeding program are in China and in Southeast Asia. But mostly the breeding program are done by the private company, and also in some case by the public research program, such as in university or research station. The most the germplasm for the breeding, the AVIDC or the World Vegetable Center in Taiwan preserve about 630 accession of the young long bean in the gene bank. And in India, the National Bureau of Plant Genetic Resource conserve about 300 accession of the young long bean. And in USA, in the USDA, they have about 195 accession. However, most of the commercial young long bean variety in Asia are developed by pure line selection or the pedigree selection method. This photo shows example of some young long bean variety in Thailand that developed by public project. We have both green pot variety and purple pot variety. And in this slide is a special variety of the young long bean we call Thua Ngu, or translate in English is the snake bean, because of the skin of this variety is very much look like the skin, the snake skin. But anyway, the cooking quality of this variety is really excellent, and some company in Thailand also sell these varieties. The trade of interest for the breeding program, we focus on fresh pod yield, pod length, pod color, and pod width, and also eating and cooking qualities. And these important diseases such as Cercospora leaf spot disease, yellow mosaic disease, bean common mosaic virus, and anthracnose. For the insects pest, the most important insect pest, I think, is pod borers, aphids, and thrips. And recently, because of the climate change, it's become really hot in summers in Thailand. So the young long bean production, the yield of the young long bean that produced in the summer decreased really significantly. So there is interested in development of new variety with heat tolerance. So in my lab, we focus on the disease resistance in the young long bean. The disease that we are focused Cercospora leaf spot disease and yellow mosaic disease. For the Cercospora leaf spot disease, it is caused by Cercospora canescens and Pseudocercospora cruenta. These two pathogens can cause the yield loss up to 40%. And this disease occur year round, but it become really serious in the rainy season. This are the symptoms. This picture show the symptoms of the serious disease on the leaves, and sometimes the spot also occur in on the pot. The disease usually occur at the flowering times. So we screen some germplasm in the young long bean and in the cowpea, and we found that some cowpea germplasm from IITA show really high resistance to the Cercospora leaf spot. So we developed populations, segregation population, F2, BC1P1, BC1P2, and we grow it in the field for disease evaluation. And we score the disease. This is our scoring system. We score from 1 to 5. And this is the distribution of the disease in the P1, P2, F1, F2, BC1, and BC2 caused by Cercospora canescens and Pseudocercospora cruenta. You can see this the pattern of the segregation of the disease caused by these two pathogens are very similar. And we test we did the chi-square test, and we found that the gene for the the number of genes that control resistance may be 1 or 2 genes. And we also estimate the number of genes using the model, the quantitative model. And we found that the number of genes control the resistance in both the Cercospora canescens and Pseudocercospora is about 1 gene. Then we map the gene that control the resistance using F2 population. We did the bulk segregation analysis in the F2 population, and then we did the linkage map and identify the QTL or the gene that control the resistance. We use the SSR marker from Scribin, Vigna anguipurata, which is closely related species to cowpea. And this is the segregation, the frequency of the segregation of the disease. We score the disease as 60 days and 70 days. Score for both Cercospora canescens and Pseudocercospora cruenta. And bulk scattering, we did a bulk scattering analysis, and we found that one marker, that is CDG304, show the polymorphism between the parents and the susceptible bout and the resistant bout. And this marker locates on the linkage group of the cowpea. So then we then we use the marker on the linkage group 9 to construct the linkage map and locate the QTL that control the resistance. We found that the resistance is between the is in the region in the marker PVM13, CDG 070, and CDG 304. And we compare our QTL, the QTL CLS 9.1 that control the resistance in the cowpea or in the young long bean, and we found that this QTL is in the same region of the QTL ALS 10.1 that control the resistance to the frog eye leaf spot in the common bean. Then after we identify the QTL that control the resistance, we did the file mapping of the QCLS 9.1. We developed the F3 derived F4 preparation from two of 3 plants that show heterozygous at QCLS 9.1. In total, we use 665 F4 plants, and we developed the new SSR markers from the cowpea reference genome, and then we use the markers for linkage map construction and identify the QTL for the resistance. This is segregation of the resistance in the F4 preparation. And we identify 2 closely linked QTL that control the resistance. We name it QCLS 9.1A and QCLS 9.1B. And we compare our linkage map to the reference genome. And in the QTL regions, we found 2 closely linked genes in the QTL CLS 9.1A and QCLS 9.1B. That is the gene YCAN10G 919300 and YCAN10G 0194000. These the first genes encode the NDP dependent malic enzyme, and this one, the second one, encode the protein dynamine related protein E. And we sequence this gene and in the parents, and we found some SNP that cause amino acid change in this gene. And also we identify the second gene, the YCAN10G 019400. We identify SNP in the gene and in the upstream sequence, and we did this the expression in the 2 genes, and we found that these 2 genes show different expressed differently in the parents, especially at the 6 hours after we inoculate the disease, the pathogen. So we believe that these 2 genes control the Cercospora leaf spot disease, and we developed marker that's specific to these 2 genes, and now we use these markers in our breeding program to transfer the gene from the cowpea to the young long bean to develop new variety with resistant to Cercospora leaf spot. Another disease that we focus on is yellow mosaic disease. The yellow mosaic disease is in the young long bean or in the cowpea causes by several strain of virus, such as bean yellow mosaic virus, bean common mosaic virus, cowpea earthworm mosaic virus, and black eye cowpea mosaic virus, and also cucumber mosaic virus. This virus can reduce yield up to 100% in the young long bean. And it's become very serious disease in the young long bean in Thailand about 5 years ago, and also in Malaysia and Indonesia. This photo show the symptom of the yellow mosaic disease in the young long bean, and sometimes the symptom also appear on the pod, the young pod of the young long bean. And we did the screening. We import some germplasm from IITA, especially the cowpea germplasm, the plain cowpea germplasm from IITA to Thailand, and we screen the germplasm from IITA together with our germplasm, local germplasm, for the resistance to yellow mosaic disease. And this is our Czech variety, and we have one resistance check from China. It show high resistance in Thailand too. And this the white cowpea that we imported from IITA. But anyway, the white cowpea also show susceptible to the disease. Most of the germplasm show susceptible to the disease, but we found that some grain cowpea germplasm from IITA show a strong resistance to the yellow mosaic disease. And this is the resistance. And some yellow bean germplasm from the local germplasm from Thailand also show resistance to the disease. This is the young long bean from Thailand that we collected from the northeast, and this show the resistance to the disease. We have developed operation to investigate the genetic that control the resistance, and we will identify the QTL by QTL sec analysis, and we will develop the marker for the resistance to the yellow mosaic disease, and develop the breeding line or the new variety by marker association. So I conclude that the two genes, that is the NDPME and DRP1E, are candidate gene for the resistance for the Cercospora leaf spot disease and small cowpea accession from IITA and local young long bean accession were highly resistant to yellow mosaic disease and can be used in the breeding program in Thailand. And thank you for your attention.
Thank you very much, Dr. Prakit. We invite the participants to add their questions in Q&A for Dr. Prakit. Okay, we have question number 1. In your opinion, what are the preference of long bean in Southeast Asia in 3 years?
Pardon?
In your opinion, what
Yes.
are the preference of long bean in Southeast Asia in 3 years?
Uh, it's hard to say that, but I think the variety that the farmer people now in Thailand or in Southeast Asia, the variety should be resistant to the yellow mosaic disease and also tolerant to heat stress.
Okay, thank you. We will move to the next question. What are the key genetic traits targeted in cowpea breeding?
I think you mean the Yanlong. I know the question may be Yanlong bean breeding or cowpea breeding. I'm not sure, but for the Yanlong bean breeding, we are focusing on the eating quality and the pod yield, the fresh pod yield, and the disease resistance, and also the insect resistance. But the insect resistance maybe is quite difficult. But for the disease resistance, I think it's not so difficult to develop the Yanlong bean with resistance to the disease.
Thank you. The next question we have is, what is the status of phytoplasma in Thailand? Is there any resistance?
The phytoplasma in Thailand, we don't have much problem with the phytoplasma in Thailand.
Thank you. Next question is there any commercial YLB variety having resistance to GMV?
GMV, now there's some variety that show resistant to the virus, but I'm not sure it is GMV or not, but I think it's a yellow mosaic virus.
Thank you. Next question. Based on your experience, what is your opinion to changing breeding program of YLB into hybrid YLB?
Based on my experience, I think it's quite difficult to develop to change the breeding of Yanlong bean into the hybrid Yanlong bean because the pollination, the outcrossing in Yanlong bean is very low. And to produce the hybrid Yanlong bean, I mean, in terms of commercial production, is maybe quite expensive for crossing by hands because the low outcrossing in the Yanlong bean.
Okay. Next question. So, what are the particular condition under which these diseases thrive?
For the Cercospora leaf spot, the wet and humid condition, the fungus, I mean the Cercospora carnescens and Pseudospora cruenta grow very it will become very aggressive under wet and hot and wet condition.
Thank you. We will give few more minutes for participants to ask more questions. Okay, we have the next question. What genetic mechanisms provide resistance against bacterial and fungal infections in long bean?
I do not get this question, but mechanism. What do you mean by the genetic mechanism? Usually, based on my experience, the number of gene control the resistance is only 1 or 2 genes.
Okay. The next question here is, what is the percent of yield difference between OPYLB and F1YLB?
Sorry, I don't know. I cannot answer the question because in Thailand we don't have F1 yard long bean. In Thailand we have a pure line, or you can say it's OP yard long bean. So I don't know the difference, the performance between the OP and the F1 yard long bean. But I think in China also they also have they use the pure line, not the F1. But I'm not sure in India.
Thank you. Next question is, now that you have resistance for Cercospora and for MYMIV, what is going to be your next breeding target or research focus?
Now we are trying to transfer the resistant gene for Cercospora leaf spot disease and the MYMV to the public variety, our old variety. And next, we will focus on some trait that related to eating quality. As I mentioned in one of slide that we have one special, very special native local variety that is tuomu or snake bean with really excellent cooking and eating quality. It's really creepy. So one of my students she is trying to identify the gene that control the eating quality or the fiber content of the tuomu.
Thanks. Next question, if I found current variety having purity or segregation issue, what can we do?
If I found current variety having purity or second issue, what can we do? But if I found current variety having purity or so you should reselect or to try to do the purine selection again in your preparation.
Okay. Moving to the next question. What is the estimated long bean market size in Thailand?
Sorry, I don't know the market size of the young long bean in Thailand. Sorry, I cannot answer this question.
Next question. Have a salt and waterlogging tolerance in long bean? Is there salt and waterlogging tolerance?
In the young long bean itself, I think the germplasm that express salt tolerance and waterlogging tolerance, we don't have such kind of germplasm. So in my breeding program or in our project, we use the germplasm we use the grain cowpea to screen for the resistant to salt tolerance and water logging tolerance.
Thank you. The next question here is it only 2 QTLs or there may be more for aphid resistance?
Aphid resistance. Sorry, I don't know about the aphid resistance because I didn't study the aphid resistance.
Thank you. I think that is the last question here for today. Thank you, Dr. Prakit, very much for this informative talk.
Thank you.
Thank you. And I would like to thank all the 3 speakers today. So we had Dr. Gangashetty, who shared with us the commitment of ICRISAT for development of Pigeonpea hybrids and how they have created hybrids that produce 30 to 50% increase in yield but still face challenges like CMS breakdowns and having very long maturity days. And they're trying to they have standardized the seed parent traits and moving towards annuality so that they can have short time maturity. And they're continuing to work on resolving these challenges to help the farmers. And we heard the talk from Dr. Manoj Phalak and about the story of developing hybrids in cowpea and Indian beans and how they identified high heterosis using EMS, and also their efforts in GMS were shared. In using also they shared us about cytological studies in validating the fertility status and how they can have more than 100% heterosis in a regular season and 200 or up to 250% heterosis in off season. So this has changed information. And then we have Dr. Prakit, who shared with us the studies of yardlong and its resistance and susceptibility to Cercospora and also yellow mosaic disease, how they've identified the QTLs, developed markers, and used them in integration of their Cercospora resistance, and identified several accessions that had resistance for yellow mosaic disease. So thank you to all the speakers for sharing very informative presentations today with the participants.
Thank you so much, Dr. Reddy. That was an amazing recap that you just gave of all the presentations that we had today. I just once again want to thank all the speakers for taking the time out to join us on this the very first session of the APSA Breed Better webinar series. Today's session was on legumes. Before we end, I would like just to give everyone a quick update. So the next, hold on. So the next session of the APSA Breed Better webinar series, session 2, will be on biotic stress resistance, and it will be on the 27th of June 2025, again from 2 p.m. to 4 p.m. Okay, and right after this, all of us we're going to send an email to all of the participants. In the email will be a small link where we ask everyone to please help to click on the link and answer our little survey regarding today's webinar. And for all those who have answered the survey, will receive a e-certificate of attendance for attending today's webinar. And for today's webinar, all the presentations and the video recording will be shared and available on the APSA website. Just go to the event page. Once again, I want to thank everyone for attending the very first session of the APSA 2025 Breed Better TGIF webinar. And I hope everyone has a great day, have a great weekend, and I'll see you next time. Thank you very much, everyone. Sawasdee ka. Bye-bye.